Okay, so students, in last lecture we have discussed about the service provided by the transport layer, right? Today we are going to discuss the protocol with the name of TCP, that is a transmission control protocol. This protocol works at the transport layer. This is the connection oriented protocol. Whatever we have discussed, the features of transport layer or the functions that is performed by the transport layer, these all features, these all functions are implemented with the help of this protocol. If we can discuss about the transport layer, the most important topic in this is the TCP protocol, as we have the TCP/IP protocol suite on the name of this. So TCP, it's a connection oriented protocol. I think you understand the term connection oriented versus connectionless. In connection oriented, when we need to transfer the data, first we need to establish the connection, then the data transfer is made. Now it will create a virtual connection. That means it is not going to create some physical connection. It is going to create virtual connection, then transfer the data. When the all the data is transferred, then this connection get terminated. It connection oriented virtual connection, then it also perform the flow and error control at the transport level. At transport level means it has nothing to do with the data link layer. It will perform the error control and flow control after the data link layer, right? So we are going to discuss in detail first we can discuss the stream delivery means one is your sending process, another one is receiving process. There's direct connection between the process and process, that is peer-to-peer connection, what we can call peer-to-peer connection. For this process, sending process and receiving process, everything comes into the stream of bytes. That is direct connection between the TCP at source end and TCP at the destination end. Now then, buffer, how we can define the buffer? Obviously buffer is a space where we can store the temporary data, right? As you can see on the first, we can discuss about the sending process. On sending process, on left hand side, it is in the circular form means the parts in blue, these are packet that has already been sent, and this circle continues in the clockwise direction, and next in the pinkish, the packet are currently not sent. When it comes to the destination end, this comes into the reverse order, right? The other packet that is currently not read, and next byte that is to be received, and this circle continues. I repeat, on source end we have a buffer that works in the circular manner. The packets in blue that are already been sent. Next packet is pink packets that are currently as soon as it rotates, and next packet that is in the pointer is going to be sent with the stream of bytes. And in the source end, this moves in the clockwise direction, but the packets in pink is currently not read, right? And then next packet, that is next byte to received. Then next we have the TCP segments. Now in earlier case we have stream of bytes. In that case, next byte that need to be sent, and this is something in intermediate, what we can say segment 1, segment 2, segment 3 up to segment n, and there is H. Stands for header. And this pink, these are the various bytes. Maybe one segment consists of 3 byte, 4 byte, 10 byte, 20 byte. That depend upon the current protocol scenario. Think you understand? So what is segment? The whole message divided into the small parts. There are the number of messages, right? And the number of messages, small parts combined, and they will considered as segments, right? And each segment has the header, and this segment 1, segment 2 up to segment n, these are going to be transferred. Now, the byte of data being transferred in each connection is numbered by TCP. The number start with randomly generated number. So, what this means, like in the previous slide, we have seen there are the segments. Now, how we can identify that this segment belongs to which message, this segment belongs to which message? This is with the help of sequence number or identification number. Now, sequence segment 1, sequence number 10,001, range 10,001 to 11,000, 11,000 to 12,000. So in that way we can divide. Let's say we have a TCP connection transferring a file of 5,000 byte. Now we can divide this 5,000 byte into the 5 segments. This is what we have discussed in the USA model. The data generated by the application layer, the whole message is divided into the subparts, and this one part is called the segment, right? Now, as we can see that we have 5,000 byte divided into the 5,000, segment 1 to segment 5, from range of, for every segment we have 1,000 bytes. The value in the sequence number field of a segment defines the number of first data byte contained in that segment. The value of acknowledgement field in segment defines the number of next byte a party expect to receive. So what it means, see, the value in sequence number field defines the number of first data byte contained in this segment. Now this sequence number 10,001, then we have, this is the first data. Sequence number 1 means that is the first byte of segment 1, right? This 11,001, again 1 means this is the first byte of segment. 12,001, again this is the first byte of segment. So this is how this segment will work, that first data byte contained in the segment. Now this is the quite important term or main focus of our today's lecture, that is your TCP segment format, or how this data is transferred. So one is header, another one is data, right? So what is header? Header is what? Information added by the current layer. Information added by the current layer. Every layer will add the header or trailer, right? We have discussed in the data link layer, we have discussed in the network layer. In case of network layer, we have discussed the protocol with the name of IP protocol. IP protocol has their header, IPv4 header, IPv6 header. In that case, this is the TCP header. This is what? TCP header. Now this is very simple. First we have the source port number and destination port number. We have discussed in last lecture, port number means every process is assigned to a particular port, and this is something what we can call the port address or port number. So the process on source end will define by the source port number. The process for which this data to be generated is destination port number at the destination end. Then we have the sequence number of acknowledgement number. Sequence number used to define the current position of this segment in its original message. Let's say we have 5,000 byte original message, then we have the 5 segment, and every segment is defined by the sequence number this to this. Let's say sequence number 1 10,010, that means what? 10,010 means what? This is the segment 1 10th byte. We have the sequence number 12,050, that means what? Segment 3 and 50th byte. So this is how the sequence number defined. Let's say the same, we have the UID in your class. Roll number 1, roll number 2, roll number 1 is at the first position, second is at the second position. This is something that used to define the some kind of arrangement, right? Sequence number used to define some kind of arrangement. Okay, now acknowledgement number. Now when we send the data to the destination reply with some sort of that we have received till that point of data, so it reply with the acknowledgement. Acknowledgement is a control signal. Now acknowledgement number that define that we have received data till that segment, then you can send data from the next segment, right? Now Then we HLEN, that is your header length, that defines the total length of this header. Reserved bit, that is used for the further use. Window size, that is very important. Window size, we have already discussed. Window is used in what? Flow control mechanism. We have checked the go back and selective repeat and sliding window protocol. We will normally take a number that is n. Now this n defines the window size. Window size used for what? Flow control. Checksum, window is for the flow control. Checksum is obviously what? Redundant bits. Checksum is what? Redundant bits. These redundant bits are added for what? These are added to check whether there is an error or not. Urgent pointer. Pointer is what? That points to something. If there is some urgent data that needs to be sent over the transmission medium, then this urgent pointer is set to that particular data. Then we have the 6 flag: URG, ACK, PSH, RST, SYN, FIN. Now URG stands for what? Urgent flag. The value of flag is either 1 or 0. Flag used to define some kind of status. If value of this urgent flag is 1, that means urgent, there is some urgent data. Acknowledgement. If value of this acknowledgement flag is 1, that means our data contains the acknowledgement. Push, PSH stands for your push. That is used for push the data. That our channel has established a connection. Now you have to start the communication. Go for push the data. RST, restart. RST means your restart, right? Whenever we need to restart the connection of something, we can say restart something, there's some error, something will happen, we need to restart again, then we will set this bit 1. SYN stands for your synchronization. SYN stands for your synchronization. This synchronization is flag that is used during the connection establishment. We will discuss in detail in further PPTs. Synchronization used in connection establishment. FIN stands for your final, that is used in the connection termination. So I'll repeat this header. We have source port number, we have destination port number. They are related with the process address. We have already discussed it. Sequence number, that is deal with the segmentation. When we'll divide the whole message into the segments, every segment has consist of bytes, and every byte is represented some kind of sequence number. Acknowledgement number, obviously it is also some sort of acknowledgement that we have received till that sequence number. You will need to send next one. HLEN, that used to define the header length. Reserved, that is used for the further use. Window size, that is used for the flow control. Checksum, that is used for the error detection. Urgent pointer, when we need to send some kind of urgent data. Pointer, that is some kind of reference that points to some data that is the urgently need to be transferred. Then we have the 6 flag: urgent, acknowledgement, push, restart, synchronization, and final. Final used for connection termination. Synchronization used for connection establishment. Restart, need to restart the whole system. Push, need to send the data. Acknowledgement, destination will acknowledge for the data. Urgent, we have some urgent data that need to be transferred. I hope you understand, right? Then we have the control flow. These are discussed in detail. Urgent, acknowledgement, push, restart, synchronization, final. Now URG, urgent pointer, is valid. That means what? Currently the data sent is urgent data, and urgent pointer will point towards this data. RST, reset the connection. RST, reset, restart, restart the connection. Acknowledgement is valid. Valid means what? Whenever the value is 1, that means it is valid, otherwise it is not valid. Sync, synchronize sequence numbers. Request for push, termination the connection. Now this is the detailed description that value of urgent pointer is valid, push the data, reset the connection, synchronize sequence number during the connection. Now see, this is the thing we are talking about. We have the client, we have the server. earlier we will use the synchronization number SYN. A means your acknowledgement. First we will create a connection. This is the connection establishment using a three-way handshaking. Now first it will send the synchronization with the sequence number 8000, right? So whenever destination receive, it will reply with the sequence number 15000 and acknowledgement 8001. Why it is 8001? Because source has sent the sequence number 8000, it reply with next sequence number, that is 8001. So it will reply with sync plus acknowledgement. It will send with the sync data only. The value of A is 0 and SYN is 1. In case of client sent to the server, the value of A is 0 and value of sync is 1 and sequence number is 8000. It replies, server reply with the sequence number 15000 that I need to send the packet started from the 15000, acknowledgement 8001. That means you have sent me the packet 8000. I have received, now send me the packet started from 8001. And sync plus acknowledgement, that means value of S field is 1 and value of A field is 1. Now client send with the acknowledgement, I have received your data, and it will send the acknowledgement, then connection is connection is established and sequence number 8000. This time it sent the sequence number 15000. So which acknowledgement number it will generate? 15001. So I hope you understand. This is the connection creation. First it will send the sync data, reply with sync plus acknowledgement, then it reply with acknowledgement. Every time I send the sequence number 8000, the opposite party reply with the acknowledgement 8001. If I send the sync 15000, opposite party reply with the acknowledgement number 15001. So this is how it will work. This is how this flag will be used. Sync and acknowledgement flag will be used for the connection creation. Now sync segment cannot carry the data, but it consume one sequence number. Sync and acknowledgement cannot carry the data but contain one sequence number. Same in case of acknowledgement number, but acknowledgement number does not consume any kind of sequence number that you can see in that picture. If in last we have the only acknowledgement number, it cannot consume any kind of sequence number. Now this is the data transfer. First sequence number 8001, acknowledgement number, then A. Here which field comes into the picture? P. P means push for the data. P means push for the data, and it will send the data. Data bytes from 8001 to 9000. That means it has sent the first segment, right? One segment is of 1000 bits. Then it will send the next sequence number 9001. That means sequence number define the segment first byte. If segment is from 8000 to 9000, sequence number is 8001. If segment is from 10,000 to 11,000, sequence number is 10,001. Right? I think you understand this term. We have discussed in that how we can define the sequence number. In that case 5000, how we have 5 segments, sequence number 1000, 10,001, 11,001. In that way it will work. So it will send the sequence number 8001, waiting for acknowledgement 15001. Now again it will send the next data with the sequence number 9001. A and P is okay, right? Now server reply with the sequence number 15001 and acknowledgement 10,001, right? It is just an acknowledgement, so it will send the data 15,000 to the 17,000, right? Goes from their side, the sequence the segment is of, let's say, 2000 bytes. Again source will send the data sequence number 10,000 and acknowledgement 7,001. What it means? It has sent the data till 17,000. It has received and it reply with the 17,001. 17,001. Are you understand this term? And sequence number 10,000. Whatever the acknowledgement, it will send that data, right? So in that way it will work. RWND reverse window, like it will send the 10,000 data, right? So see, there are two party 1, party 2. Party 1 send sequence number 10, acknowledgement number 20. Then party 2, what if party 2 will do? It will send the data with the received acknowledgement number. Let's say acknowledgement number was 20, so it will send the data of 21. To send the data of 21. So that's the whole process. You can see 1 to third one. When it generate the acknowledgement number 10,000, it generate the acknowledgement number 10,001. Next time on fourth, it will send the data with sequence number of 10,000. This is how the data transfer will take. Now connection termination using the three-way handshake. First we have discussed about the connection creation, right? Connection creation, we need the synchronization acknowledgement. Data transfer, we need the acknowledgement and push pointer. In that case, we need the acknowledgement plus final. In active, first it will send the sequence number X, acknowledgement Y, F money final. I have done with my transfer. Now terminate the connection. Now server reply with the sequence number. Its acknowledgement is Y. On other side, then sequence number is Y. Acknowledgement number is X plus 1. Because sequence is X, it receives the acknowledgement X plus 1. Now, then other side reply with the sequence X and acknowledgement Y plus 1. Now on last we have only acknowledgement. On first we have the final. On second we have final plus acknowledgement. In same case we have with that. First we have sync packet, then sync plus acknowledge, then we have acknowledgement. In that case, we have final, then final plus acknowledgement. On last we have acknowledgement. So this is how the connection termination will do. Now these are the simple things that final segment consume one sequence number, final plus acknowledgement consume one sequence number, right? But only acknowledgement does not consume any kind of sequence number. So this is how your TCP works. And now TCP is what? Transmission Control Protocol, that has their header, they have their 6 flags, they have the source port number, they have the destination port number, they have the sequence number that is used for the flow control, sequence number, acknowledgement number and window size that are used for the flow control. Then we have the header length, checksum is used for the error detection, and then we have the urgent pointer. That urgent pointer is used when we have some control data, that is the urgent data that need to be transferred through the transmission medium. Thank you.